Mr. Lucier's chemistry!
Hello everybody, welcome back to chemistry. Today we're starting our acid-base unit. So today we're going to be talking about acids and bases. For the most part, we're going to be looking at characteristics of acids and bases. Now let's go ahead and get this started. When we have acids here, when a solution is an acid, we say it's acidic. Okay, when a solution is an acid, we say it's acidic. And when a solution is basic, well, we call it basic. But we also use another name called alkaline, alkalinity, right? That solution is alkaline. So I'm going to write that here too, alkaline. So when we're saying a solution is basic or alkaline, it just means the same thing. Okay, so don't get caught up on the definitions. It just means we're looking at a base here. We're going to look at the differences between acids and bases. But let's get some misconceptions out of the way real quick. We all know acids are super caustic, acidic, they'll burn. We've seen it on TV and movies and stuff. They talk about acids. And this is the symbol right here. You know, it's a little burning piece of metal or something. And we say acids are all corrosive. Well, bases are the same thing, okay? Bases are also real caustic and corrosive and can burn you the exact same way as acids will. It's like acids and bases are sides to a coin. You're looking at the same coin, but acids are one side and bases are the other. So they pretty much act the same. So real quick, let's go over some characteristics of acids versus bases. Now acids, if you were to taste acids, acids taste sour. Acids taste sour, and if you were to taste a base, bases taste bitter. For the most part, guys, our food, our body, all that stuff has acids in it. RNA, ribonucleic acid, DNA, deoxyribonucleic acid. We talk about the fruits and stuff we eat, has all the acids and stuff, and you know, even when we work out, when we work out, when we're working our muscles out, it produces lactic acid. So when it comes to our bodies and what we eat and stuff like that, it's all about the acids. So I'm going to say usually our foods have acids in it. All our different foods have different kinds of acids in it. We actually like that sour taste, especially when we mix it with sweet and stuff like that. Now bases, guys, feel slippery. And you know what that slippery feeling means. If you've ever washed your hands with soap, you know that soapy feeling? I'm going to write soapy on here, because that's what bases feel like. And we actually clean with bases. We use bases to clean, and we usually eat acids. Even the acids found in our stomach, hydrochloric acid is in our stomach, and that's what we use to digest our food. So don't forget, HCl is in our stomach. Very important. If you had to differentiate the two, we eat acids, and acids are in our body, and we clean with bases. So if they had to choose which one of these is an acid or which one of these is a base, well, just think to yourself, is it in my body, or can I eat it, or can I clean with it? And that'll tell you the difference between acids and bases, okay? If they show you a picture of a lemon, well, I can eat a lemon, that means it's an acid. If they show you a picture of, I don't know, some soap, oh, I clean with soap, so that's got to be a base, okay? So those are some common characteristics of acids and bases. Now, today we're not going to go super technical into acids and bases. We'll save that for another day. But I am going to give you the basics. So let me give you an acid-base equation. If I have HCl plus NaOH. This is an acid and a base. How do I know it's an acid? Because all acids start with hydrogen. And how do I know it's a base? Because bases end with this hydroxide. We're doing basic definitions today, okay? This is an acid because it starts with an H. This is a base because it has an OH in it. This is a double replacement reaction, so the two back guys are going to switch. What makes an acid, and we'll learn more about this later, is acids will dump H into solution, and that's what makes it acidic. And bases dump hydroxides into solution, and that's what makes it basic or alkaline. So the more hydroxides you have in solution, the more basic it becomes. The more H's you have in solution, the more acidic it becomes. But if you start dropping both of them in solution, they actually cancel each other out. This is what we call a neutralization reaction. Let me write this down. Neutralization reaction. This is a neutralization reaction. And what's happening here is the H is going to get with who? Because remember, the two back guys are going to switch. Him and him's going to switch. So this hydroxide is going to get with the H, and you're going to end up forming HOH. And what is HOH? That's water. Water. You're used to seeing it as H2O, but really you write it HOH. And what else is formed? You form sodium in A, gets that Cl, and this is a salt. So all acid and base neutralization reactions form the same two products every time. You form water, and you're going to form some sort of salt. NaCl is not the only salt on this planet. If you take group 1 and 2 metals and mix it with group 17 nonmetals, you'll always get a salt. We call them salts. You know about NaCl, that's the salt we eat, but there's other salts that we don't eat, but we still call them salts. So, remember what I'm saying. Neutralization reactions, when you mix an acid with a base, you always get salt water. You always get salt, and you always get water. So this is your basic neutralization reaction. We measure acidity or alkalinity. Remember, alkalinity means basic. We measure acidity and alkalinity on this thing we call the pH scale. All acids have a pH below 7. All bases have a pH above 7. And when the two acids, when the acid and the base cancel each other out, we get a neutralization. When it's neutral, neutral has a pH of 7 exactly. Okay? So acids have a pH below 7, bases have a pH above 7, and when it's neutral, because they cancel each other out, we have a pH of 7. And our body maintains a pH of around 7. Now let's talk about some indicators. How do we know we're dealing with an acid or a base? Well, we use this stuff. We use a couple of things. We use pH meters now, but mainly in the past, and some people still do, we use indicators, okay? We have pH strips, right? We call this litmus paper. We have litmus paper, and that's what these three guys are. You have red litmus paper, blue litmus paper, and even purple litmus paper now. And we even have pH strips now where you just dump it in and you compare it to the package and it'll tell you exactly what the pH is. But let's talk about the litmus paper today, okay? Now here's the way litmus paper works. I'm going to write two categories. What color does it turn in an acid, and what color does it turn in a base? Okay, those are going to be my two criteria. Now if I take red litmus paper and I stick it in an acid, there is no change in C. No change. It stays red. But if I take blue litmus paper and I stick it in a base, it actually turns the litmus paper blue. Okay? It turns it blue. So I'm going to write blue. So red litmus paper is really for using to see if something is basic or not, right? Because if I stick red litmus paper in water, it's not going to turn any colors. So I don't know if it's an acid or not. But if it turns blue, I for sure know that it's a base. So we use red litmus paper to determine if something is a base. Now, let's look at blue litmus paper. If I stick blue litmus paper in an acid, it turns red. Okay? If I stick blue litmus paper in an acid, it's going to turn red. And if I stick blue litmus paper in a base, there is no change. So what do you think we use blue litmus paper for? Well, if I stick blue litmus paper in water, there's also no change. So that means blue litmus paper must only be used for determining if something is an acid. So in the past, I would have a solution and I have to determine, okay, is this an acid or a base? I'd get red litmus paper first and stick it in. I'd get blue litmus paper second and stick it in. I'd look at it, okay, did either one of these turn colors? But I'm still using 2 litmus papers, and that costs money. Well, later on down the road, they come up with this stuff, the purple litmus paper. So the purple litmus paper would actually turn red in the presence of an acid, and then it would turn blue in the presence of a base, which was kind of cool because now all I had to do was buy one type of litmus paper, and pretty much that's what the standard went to, was the purple litmus paper, where acids turn red and bases turn blue. And it's still that way today. Acids turn red and bases turn blue. So this is litmus paper, guys. It's for determining whether an unknown solution is acidic or alkaline. Alkaline meaning basic. So then we came up to this stuff called phenolphthalein. It's a clear solution. And what you do is you take this dropper, it's a dropper, and you put a couple drops in solution and then you mix it around. Well, if it stays clear, right, there's no change. You can see, no change. But if the solution turns hot pink, that means it's basic. Okay? If the solution turns hot pink, that means it's basic. So if you put a couple drops in this and the whole solution turned hot pink, you're like, oh man, that's an alkaline solution. That's a basic solution. It turned hot pink. So these are different indicators we can use to determine whether something's acidic or basic. There are other indicators. There are other pH strips. We even use pH meters now for determining pH exactly. But again, the more technical you get, the more money it costs. And a lot of times using just the basic cheap stuff will do the trick. So there's no use of spending a lot of money on stuff. Now, one last thing. Let's talk about water. Okay? Let's talk about water. Now, here's the formula for water. H OH. Do you notice something here? What I say about acids? All acids start with what? All acids start with H. So that makes water an acid or a base. That makes water a base, an acid, I'm sorry. That makes water an acid. It starts with an H. But then again I said all bases have a hydroxide in it, right? Or produce a hydroxide. So bases have hydroxides. What do you see right here? That's a hydroxide. So what is water? Water is a base. So water, not only being the universal solvent, it's also an acid and also a base. I'm telling you, water is so unique and awesome. Water is both not only the universal solvent, but it's an acid and it's a base. And if you had to guess what the pH of water using the pH scale is, what do you think the pH of water is? If you guessed 7, you are correct. And it makes sense, right? It has H. Remember, H's have pHs below 7. Hydroxides have a pH above 7. So if water has both of them, that means it has to be neutral. So it has a pH of 7, which is neutral. So guys, this is the basics for acids and bases. We will get more technical later. I hope this helps, and have a great day.
Job's done.